Welcome back to the Daily Update. I'm Oliver, and today we're looking at June 17th, 2026. And honestly, this is one of those days where everything in AI infrastructure and economics seems to be shifting at once. We've got Anthropic dropping some groundbreaking data on how humans and AI actually divide labor in real coding sessions. We've got Chinese models suddenly undercutting Western pricing by a factor of 6. There's a policy argument brewing about whether we can even control dangerous AI capabilities. Plus, practical lessons from Vercel on why adding more tools to AI agents is actually the wrong move. And underneath all of it, builders are facing serious questions about infrastructure and lock-in. So buckle in, there's a lot.
6 times cheaper. That's the number that jumped out at me. We're not talking incremental price drops here. We're talking about GLM 5.2 and Kimi actually beating GPT 5.5 on serious coding benchmarks while costing a fraction of the price. And their open weight, which changes everything about vendor lock-in and sovereignty. But before we even get to that story, I want to understand what Anthropic's data actually tells us about whether domain expertise is more important than coding skill, because that reframes everything about how builders should approach this.
Exactly. And here's the connective tissue between all of these stories. They all come down to the same economic and strategic question. What actually matters when you're building AI-assisted businesses at scale? Is it raw model capability, cost per token, the ability to maintain your systems as models improve monthly? The answer seems to be none of those things alone. It's about architecture, about understanding what breaks, and about not getting locked into a single vendor when the market is moving this fast.
And the maintenance story from Vercel, removing 80% of their agents' tools to make it better, that's the kind of counterintuitive lesson that separates builders who ship once from builders who actually maintain systems, because this is the week where the conversation moves from "how do I build an AI agent" to "how do I keep it working" when the model inside it improves by 25% in task value every quarter. That's a completely different question.
It is. So over the next hour, we're going to walk through all of this. We'll start with Anthropic's data on division of labor, then move into the competitive landscape and what Chinese models mean for your infrastructure choices. We'll tackle the policy question, and spoiler, it's darker than most people want to admit. Then we'll spend real time on the maintenance and orchestration challenges that separate prototype from production. And by the end, you'll have a much clearer picture of where the actual competitive edges are forming in AI-assisted business building. Let's start. All right, so Anthropic just published analysis of nearly 400,000 Claude code sessions from October 2025 through April 2026. And the headline is probably the simplest finding. There's a stable division of labor. Humans make 70% of planning decisions. What to build, what the problem actually is. Claude handles 80% of execution decisions. How to build it, the technical pathway. This isn't a guess or a projection. This is actual data from hundreds of thousands of real sessions.
That's striking because it immediately tells you something about how the tool actually works in practice versus how people imagine it works. People worry that Claude is going to take over the thinking, but the data says the opposite. The human is still driving strategy and intention, and Claude is the executor. So what does that mean for a builder? It means the constraint isn't thinking. It means the human judgment piece, understanding what problem you're actually solving. That's still the scarce resource.
Exactly. And typical session looks like this. 4 user prompts trigger roughly 10 Claude actions each. So the human is sparse with their input. They're directing, not micromanaging. But here's the finding that really jumped out at me. Domain expertise determines success rates, not coding skill. Non-engineers succeed at nearly the same rate as software engineers. What does that tell you?
That the moat is domain knowledge. A person who understands trading, or music production, or electronics. They know what good looks like in their field. They know what the edge cases are. They know what the customer actually wants, even when the customer doesn't articulate it clearly. That person can extract more work per instruction from Claude than a formally trained engineer who doesn't understand the domain. It completely reframes what matters when you're building.
So if you're launching a portfolio of small AI-assisted businesses, and you've got deep domain expertise in 3 or 4 different areas, this data is basically saying that's your competitive edge. You don't need to become a better coder. You need to stay sharp in the domains where you understand the problem better than anyone else. How does Claude fit into your stack once you're comfortable with that framing?
Claude becomes the lever that lets you move faster in the execution layer. And the data backs that up. Over those 7 months from October to April, debugging time actually halved. The quality of Claude's responses improved. But here's what jumped out at me. The estimated task value rose 25% across occupations, meaning the same person is delivering more valuable work with the same amount of effort. That's the efficiency compounding.
That's the number I want to focus on. 25% task value increase in 7 months. That's not marginal. That's meaningful. And it's not because the human got better at their job. It's because the tool improved. So if you're shipping multiple small ventures at once, your tools are getting more powerful every quarter. Your ROI on early adoption keeps compounding. The report also breaks down 9 different work modes beyond just code writing and fixing. Code is only 56% of the work. 17% is operating software. 14% is planning and exploration. 13% is analysis and prose. Why does that matter?
Because it shows the boundary of what Claude Code can handle is way broader than write me a function. It's becoming a workflow orchestration tool. Someone can ask Claude to explore a problem space, plan the architecture, write the code, deploy it, document it, analyze the results, all without context switching. That compounds the velocity advantage for someone running multiple businesses in parallel. You're not switching tools constantly, you're staying in one interface.
So let's connect this back to infrastructure and lock-in. If you're relying on Claude for 75% of your execution work, aren't you just swapping one kind of vendor lock-in for another? How much does this data actually suggest you should worry about that?
That's the good news and the subtle point. Domain expertise creates optionality. If the underlying domain knowledge is yours, you can swap the tool. You can move to a different model, use open source, run something locally. But the person who only knows how to use Claude without understanding the underlying problem, they're stuck. The data shows that domain knowledge is the actual moat, not the tool. And that actually suggests you should diversify tooling, because you understand the problem well enough to work across multiple models. The tool becomes interchangeable. The domain expertise doesn't.
That's the thesis that ties everything together, isn't it? Domain expertise is the defensible edge, Claude Code is the multiplier, and the fact that task value is compounding while debugging time is dropping means the leverage on that domain expertise is only going to increase quarter over quarter. If you're going to place multiple small bets on AI-assisted businesses, this is basically saying place them in domains where you already have unfair advantage and let the tool catch up on the execution side.
So we've established that domain expertise and task value are compounding with the current tools. But this is the moment where that entire economic equation gets disrupted. 2 Chinese models just emerged from stealth, Kimi K2.7 code and GLM 5.2, and the pricing is not incremental. It's 6 times cheaper than GPT 5.5. We're talking roughly 1/6 the cost.
6 times cheaper. That's not a price adjustment. That's a market shock. But cheap doesn't matter if the model is mediocre. What's the quality story? Are these models actually competitive, or are you paying for what you get?
That's where it gets interesting. GLM 5.2 doesn't just match GPT 5.5 on benchmarks, it beats it on serious coding tests. It scores 62.1 on SWE Bench Pro, which is the test that matters for actual code completion work. GPT 5.5 scores 58.6. It also wins on Frontier SWU and MCP Atlas. And Kimi K 2.7 beats Claude Opus 4.8 on MCP Mark Verified. These aren't marginal differences on obscure benchmarks. These are the benchmarks that matter for code generation.
So you're saying that not only are these models cheaper by a factor of 6, they're objectively better at the thing we just finished discussing, code execution work. That seems impossible. How are they achieving that?
Architecture. GLM 5.2 uses something called index share, which is reducing compute requirements by 2.9x compared to previous approaches. It's 753 billion parameters, but with a 1 million token context window. That's deeper context than GPT 5.5, which means better understanding of complex codebases. And Kimi is running 1 trillion parameters, with 32 billion active, via mixture of experts, so it's efficient too. They're not throwing more compute at the problem, they're building smarter.
All right, but efficiency and architecture are engineering problems. The real question for builders is lock-in. If you've been betting on Claude Code or GPT 5.5 because they're the closed, expensive market leaders, and now these open-weight alternatives are better and cheaper, what does that mean for your vendor strategy?
That's the kicker. Both Kimi and GLM are open weight. GLM 5.2 is released under an unrestricted MIT license. Kimi requires attribution for products exceeding 100 million monthly active users, but it's still fundamentally open. You can run it locally, you can self-host, you can audit the weights. You're not locked into a cloud provider's pricing or availability.
So combining the Anthropic data we just discussed, where domain expertise matters more than coding skill, with this suddenly, a builder with domain knowledge can self-host a competitive coding model for a fraction of the cost, and they're not at the mercy of OpenAI or Anthropic's API pricing. That changes the cost structure of the entire portfolio approach, doesn't it?
Dramatically. The pricing for GLM 5.2 is $1.4 to $4.4 per million tokens. That's combined $5.80 total. GPT 5.5 is $5 input, $30 output, so roughly $35 combined. You're looking at a 6-to-1 cost advantage before you even factor in self-hosting. And the timing of this release is not random. Claude Fable 5 just got pulled offline due to US export controls. So here's Beijing basically saying, you can't export your best models to the West, and here's ours instead.
That's the geopolitical layer. But there's a commercial layer that's equally interesting. SpaceX just acquired Cursor for $60 billion all stock. Cursor hit $4 billion annual recurring revenue, up from $3 billion in April. Why does that acquisition matter in this conversation?
Because it's massive validation that AI coding tools have real product market fit. Cursor is explicitly positioning against VS Code, against traditional development workflows. And SpaceX acquiring it means Elon's getting access to 550,000 GPU infrastructure through xAI, plus Cursor's developer workflow data for training Grok. That deal signals that the AI coding IDE market is real, growing, and worth tens of billions. That's not hype. That's capital allocation at scale.
So you've got Cursor at $4 billion ARR, OpenAI preparing GPT-B1 with bidirectional audio capability for more natural conversation, and now Chinese models offering 6-to-1 price compression while winning on benchmarks. What does this convergence actually mean for someone launching multiple small AI businesses?
It means the cost of entry is collapsing. You can build serious coding tools without depending on OpenAI's or Anthropic's willingness to serve your market segment. You can experiment with different models, different architectures, different deployment patterns. You're not locked into one vendor's pricing or availability. And the validation from Cursor's acquisition tells you that there's a real market willing to pay for better tooling. That's permission to build.
And price compression will only accelerate. If GLM 5.2 is already cheaper and better than GPT 5.5, OpenAI and Anthropic will respond with price cuts, which means margins compress, which means builders can deploy more compute per dollar. The entire economics of AI-assisted business gets more favorable, faster, for the next 12 months. So, we've just watched the cost of frontier AI models compress by a factor of 6, while capability improved across the board. That's the optimistic reading. But there's a darker conversation happening underneath all of this that we need to address directly. And it comes down to a simple proposition. Powerful, potentially dangerous AI models are going to continue being developed regardless of government policy, export controls, or corporate safety pledges. That's the thesis. And if it's true, it changes how builders should think about their entire strategy.
That's a heavy claim. Let me hear the argument, because there's a spectrum of how you respond to that. On one end, you panic and assume AI governance is theatre. On the other end, you assume the tools at your disposal actually matter. So what's the evidence that frontier capabilities are genuinely inevitable?
Look at what just happened. The US imposed export controls that got stringent enough to pull Claude Fable 5 offline. That's a significant AI capability disappearing from US access. And the response from China? Within weeks, they released 2 open-weight models that are cheaper and better. Export controls create geographic friction. They don't prevent capability advancement. The capability will emerge somewhere, and once it exists, it propagates. The path to powerful AI is not a choice point we can gate. It's a deterministic process happening in parallel across multiple countries, companies, and open-source communities.
Okay, so policy can't prevent the capability from existing somewhere on Earth. That's probably true. But policy still shapes something meaningful. Who controls it, and when it arrives? If the US can't prevent GLM 5.2 from being built, maybe they can slow it down, or make sure the US has something comparable, or ensure allies have access to open weights instead of closed APIs. That's not the same as stopping dangerous AI. But it's not nothing either.
That's the precise distinction I think builders need to internalize. Frontier capabilities are coming. That's not a question. But where they're hosted, who has access, what licensing terms apply, that's still subject to policy friction. Corporate voluntary pledges are also provisional. They hold until market pressure erodes them. Then someone pays the reputational cost and builds the dangerous thing anyway. So what does a builder actually do with this knowledge? How do you position for a world where capabilities are inevitable, but access and licensing are still variable?
You build defensible positions that aren't dependent on any single capability or provider. This is actually why the Anthropic data we discussed earlier mattered so much. Domain expertise is your defensible moat, not the specific model you're using. You avoid building your entire stack around Claude, or around GPT 5.5, or around any closed API. You build systems that can migrate across models as the regulatory landscape shifts. You have a plan for what happens when your preferred provider gets hit with export controls, or suddenly increases prices by 3x, or deprioritizes your market segment.
So that's one implication, architectural optionality. Don't get locked in. But there's something deeper happening in how Anthropic and OpenAI are responding to this inevitability. They're not just racing to build better models. They're building what the analysis we reviewed earlier called harnesses, comprehensive workbenches of tools, permissions, integrations, memory systems, audit trails. Why do you think they're doing that?
Because they understand that frontier capability alone is useless without control and governance. A more powerful model that's uncontrolled and auditable is actually more dangerous to deploy than a slightly weaker model with comprehensive safety harness around it. And from a business perspective, the harness is the actual moat. The model inside gets displaced by cheaper open-source competitors, but a well-designed harness, one that handles enterprise security, governance, compliance, model routing, cost optimization, that's something you can't just replicate by downloading weights. That's why both companies are investing so heavily in orchestration layers and comprehensive tooling. They're essentially conceding that raw capability is becoming commoditized.
And this ties directly back to the portfolio approach we've been discussing. If frontier capabilities are inevitable and commoditizing, then the competitive edge isn't owning the model. It's understanding your domain well enough to deploy any capable model effectively, and building flexible systems that don't assume any particular vendor will own the future. For someone launching multiple small AI businesses, that means stay vendor agnostic, keep your systems portable, invest in understanding your domain better than your competitors understand theirs, and expect that the policy landscape will shift faster than you can keep up with.
So the practical upshot is this. Don't pretend you can predict which policy regime sticks, or which vendor survives, or which model stays available. Instead, build businesses where you have unfair advantage in understanding the customer problem, and you're flexible about which AI tools you use to solve it. That actually positions you better than anyone betting their entire strategy on being an early adopter of a specific closed model. You're diversified, you're defensive, and you can respond faster when the inevitable disruptions happen. Alright, so we've been talking about how to build AI systems, but nobody talks about what happens after you ship. Vercel just released some analysis of their sales agent, and the finding is completely counterintuitive. They improved it by removing 80% of its tools. Not adding, removing. They made it simpler and more effective at the same time.
Wait, that's backwards from how people actually think about building. Most teams ship an agent with 5 tools, then add 10 more when it doesn't work perfectly. Why would removing tools make the agent better?
Because most of those tools create surface area for failure. But here's the real insight. Agents break in 2 different directions. First, they break when the world around them drifts. Your data gets stale, your APIs change, your business process evolves. Second, and this is the subtle one, they break when the model inside them improves. Yesterday's protective guardrails that kept a mediocre model from hallucinating now trap a more capable model and prevent it from doing useful work.
So you're saying that as Claude gets better every month, an agent that was perfectly safe and balanced 3 months ago is now actively worse? It's constrained by guardrails that made sense for an older model?
Exactly. And Vercel figured this out the hard way. They studied their top sales reps' actual workflow, not what's written in the SOP, but what they actually do. They built an agent around the repeatable patterns and kept humans in the review loop. Then they iterated by removing tools that weren't adding value. The agent didn't get fewer capabilities, it got clearer about what it was supposed to do.
So the question becomes, how do you know which tools to keep and which to remove? Vercel clearly had a framework. What does maintenance actually look like for something like that?
This is where the concept of the harnesses becomes critical. Think of it as the workbench around the agent. Everything except the model itself. It includes what the agent reads, what it's allowed to touch, what it remembers, what proof it must provide before taking action, and what's strictly forbidden. Maintaining an agent is really maintaining that harness. And it's nothing like traditional software maintenance.
Why not? Software maintenance is maintenance, right? You patch bugs, you update dependencies, you fix regressions.
Agents inherit all the crud of the systems around them. Your wiki gets stale, your SOPs drift, your definitions of what constitutes success change, and suddenly the agent is acting on outdated information. That's not a bug, that's entropy. Vercel had to ask 5 specific questions to stay on top of it. What's the agent eating? What sources of truth is it reading? What can it touch? What permissions has it actually got? What's its job? Is that still the real job, or has the business moved on? What proof does it require? Is that proof still meaningful, and does it still add value? Because if you're spending more time maintaining the harness than you're saving with the agent, the answer is, delete it.
Those 5 questions are basically asking, is this harness still aligned with reality? And the honest answer for a lot of deployed agents is probably no. The model improved, the business changed, but the harness stayed the same.
Right. And here's the thing that separates builders who ship prototypes from builders who maintain systems. The mature question isn't, what should I add to this agent? The mature question is, what should I delete? Stuart Brand wrote a whole book called The Maintenance of Everything, about how civilization fails at maintenance. Systems accumulate cruft faster than we can clean it, and agents are the same, except worse because they're acting autonomously on that cruft. One stale API integration, one misdefined permission, and the agent cascades into failure.
This is actually more like sailboat maintenance than software maintenance, isn't it? A sailboat doesn't get better because you add a seventh sail. It gets worse. And if you don't maintain the existing sails, the whole thing sinks.
That's exactly the metaphor. You can add a new sail, but something else has to come off, or the boat capsizes under the weight. The maintenance work is mostly invisible. You're checking rope, replacing canvas, making sure the hull is still sound. And the moment you stop doing that work, the boat fails, not because of a new problem, but because of invisible decay.
So for someone launching multiple small AI businesses, this is critical. You can't ship an agent on day one and forget about it. Every agent is a debt obligation. Every month you don't spend time reviewing those 5 questions. What's it eating? What can it touch? What's its job? What proof does it need? Does it still add value? That debt compounds. And unlike traditional tech debt, agent debt degrades faster because the model keeps improving.
And here's the strategic insight. This is why both Anthropic and OpenAI are building these comprehensive harnesses we talked about earlier. They're not just building better models, they're building tools to make harness maintenance manageable at scale. Because if they don't solve this problem, enterprises won't deploy agents in production. They'll be too terrified of the maintenance burden. GitHub just announced that code quality is exiting public preview and going generally available on July the 20th, 2026. This has been tested by more than 10,000 enterprises during the preview phase. The core capabilities are straightforward: maintainability detection, reliability issue detection, quality gate enforcement, and code coverage tracking. So GitHub is essentially building integrated quality checks into the platform itself.
10,000 enterprises is real validation. That's not a niche feature being tested by early adopters. That's enterprise-grade infrastructure actually in use at scale. But I want to understand why this matters for someone building multiple small AI businesses fast. Isn't code quality tooling just another thing that slows you down when you're trying to ship?
That's the exact wrong framing, and code quality addresses it. The whole point is that it's integrated directly into your workflow, into GitHub, where you're already pushing code. You're not switching tools, you're not running separate linters and coverage tools and checking results in another dashboard. It's native to the platform. And when you're managing a portfolio of small projects, technical debt compounds across all of them if you're not careful. This tooling lets you catch reliability issues and maintainability problems before they cascade, without adding friction to your shipping velocity.
So the idea is that quality checks become so cheap and integrated that you can't afford not to use them. They're not slowing you down, they're actually preventing you from accumulating maintenance burden that would slow you down later. That fits the pattern we've been seeing all episode. Automation and integration that make good practices the path of least resistance instead of the path of most resistance. If you're shipping fast with many bets, code quality going GA means you've got one less thing to custom build or manually manage across projects.
Alright, so we've been talking about infrastructure and lock-in for a while now, but here's where it gets really interesting for someone building locally. There are 2 stories converging that I think are underrated. First, there's a tool called Hermes Agent that's essentially turning local language models from chat interfaces into autonomous systems that can actually do stuff. Second, there's a builder who documented that 2 salvaged older GPUs together outperform a brand new $2,000 GPU for AI workload. That's not just a hardware story, that's an economic story.
Okay, so Hermes Agent, what does it actually do? Because there's been a bunch of tools claiming to make local models practical. What makes this different?
It bridges the gap between a chat box and an actual autonomous system. Hermes Agent adds execution capabilities to local language models. We're talking about scripts, file operations, scheduled jobs. So instead of a local model sitting on your machine that you can ask questions, it becomes a system that can manipulate your local environment. It can run commands, it can manage files, it can schedule workflows. You're turning a passive chat interface into an actual agent that does work.
So now I'm curious about the salvaged GPU story because that feels related. If Hermes Agent is making local models actionable, and older hardware can match or beat new premium cards on inference workload, suddenly running this stuff locally becomes economically viable. What's the actual comparison here?
Two salvaged older GPUs. We're talking hardware that's years old, probably pulled from systems that were upgraded or retired. Together they handle more AI inference workload than a single brand new $2,000 GPU. And the builder who did this, they documented it. They have zero plans to upgrade. Why would they? They've got a multi-GPU configuration that distributes the load more efficiently than one monolithic card. They paid a fraction of the price, and they're handling more throughput. It's a direct challenge to the assumption that AI requires cutting-edge hardware.
This completely changes the cost structure for running this locally, doesn't it? Because if you combine Hermes Agent's capabilities with salvaged hardware economics, you're not paying cloud API costs, you're not locked into OpenAI or Anthropic's pricing, and you're using hardware you can scavenge for. For someone building a portfolio of small AI businesses on a tight budget, what does that actually unlock?
It unlocks experimentation at scale without the cost penalty. You can run multiple models, you can test different architectures, you can build agents, run them locally, iterate without watching your token costs climb. And crucially, and this connects back to the policy conversation we had earlier, you're not dependent on cloud provider availability or pricing changes. If OpenAI suddenly increases API costs by 50%, you're fine. If export controls shut down access to a particular model region, you've got local fallbacks. The hardware costs drop, the vendor lock-in drops, and the barrier to trying new things drops with it.
And because we've established that domain expertise matters way more than coding skill, and that maintainability of agents is about the harness, not the model, this actually suggests that running things locally and staying flexible across models is exactly the right architectural choice for someone building multiple ventures. You're not betting everything on a single provider's model and pricing. You're building on infrastructure that you control.
Exactly. And this is the moment where the infrastructure picture becomes clear. You've got Claude code available for execution when you need cloud-grade capability. You've got open-weight models like GLM and Kimi that you can self-host if you want cheaper inference. You've got Hermes Agent making local models actually actionable instead of just conversational. And you've got salvaged hardware proving that you don't need premium gear to run serious inference. The constraint is no longer, can I afford to run AI? The constraint is, do I understand my domain well enough to use these tools effectively? And that's a constraint that shifts the game entirely to the builders with actual domain expertise.
Okay, so we've been talking about builders managing their own infrastructure and avoiding lock-in. But there's a parallel problem happening inside enterprises right now that's getting almost no attention. A Spanish startup called Optiac just emerged from stealth with €4 million in pre-seed funding to solve what they're calling shadow AI sprawl. And the problem they're addressing is real. 46% of organizations experienced internal data leaks from unsanctioned AI use last year. That's not a rounding error. That's nearly half of enterprises.
Wait, so employees are using personal ChatGPT accounts or random AI tools they found online without going through official channels? That's the shadow part?
Exactly. And IBM data from 2025 suggests that shadow AI accounts for roughly 20% of all breaches. So we're not just talking about people accidentally leaking confidential data to ChatGPT. We're talking about it becoming a material security problem. Employees are making trade decisions or using internal financial data or analyzing customer information, and they're doing it on whatever free AI tool they found on the internet. The enterprise has no visibility, no control, no compliance trail.
Okay, so Optiac's solution is to, what? Mandate that everyone uses a particular AI tool instead? That sounds like it would just push shadow AI deeper underground.
That's the elegant part. Optiac isn't trying to be the tool. They're building what they call a neutral orchestration layer, single intermediary sitting between all an enterprise's AI applications and the underlying models. That layer handles security, governance, memory, observability, and cost routing. But critically, it doesn't force lock-in to a single model or vendor. The enterprise can route requests to whatever models it permits: Claude, GPT, open source, internal models. The orchestration layer doesn't care. It just enforces policy.
So the idea is that if you have one approved gateway for AI, where everything has to go through Optiac, then you get visibility into what's happening. You know what data is being sent where. You can route to cheaper models when it makes sense, or to more capable models for harder tasks. And employees can't bypass it and go to random AI tools because that's easier than the official path.
Precisely. And the team they've assembled suggests they understand this problem at depth. The co-CEOs are Daniel Arenas and Ignacio Gamoneda. The CTO is Borja Bale, who came from Google DeepMind and Amazon, where he specialized in differential privacy. That's not a random hiring. Differential privacy is about how to compute on sensitive data while proving mathematically that you're not leaking information about individuals. That's exactly the expertise you need to build governance layers that enterprises can actually trust.
So they're not just routing requests, they're actually thinking about the privacy architecture underneath. That's sophisticated. But I'm curious about the go-to-market angle. Enterprises are notoriously slow to adopt new infrastructure. How are they planning to get traction?
They're running what they call a design partner program, essentially co-designing the solution with large enterprise customers at scale. They're not shipping a generic product, they're building it with real enterprises that have shadow AI problems. Funding came from Market One Capital, Next Tier Ventures, Plug and Play, and Mission, and they're already being called the second largest enterprise AI round in Spain for 2026.
Okay, but I want to connect this back to what we've been discussing all episode. We spent a lot of time talking about how builders should avoid vendor lock-in and stay flexible across models. Optiac is essentially enabling enterprises to do exactly that. They can use Claude for some workloads, GPT for others, open source for cost-sensitive tasks, and they're still compliant and secure. But there's a deeper pattern here, isn't there?
There is. It's the same pattern we saw with Anthropic and OpenAI building comprehensive harnesses. The real competitive advantage isn't owning the model anymore. It's owning the orchestration layer between the user and the models. Optiac is doing this for enterprises. The framework they're building, cost control, model routing, avoiding lock-in, centralized governance, that's exactly the infrastructure pattern that matters when you have multiple AI applications running in parallel.
And for someone like the builders we've been talking about, launching multiple small AI ventures, this actually applies in miniature. You don't need to license Optiac as an enterprise, but the framework they're solving for is real. If you're running Claude Code for execution, a local open source model for inference, maybe GPT for voice work, you need some way to route requests intelligently, track costs, and make sure you're not accumulating technical debt or lock-in across all of them. The orchestration layer pattern is how you avoid that trap.
And it reframes how you think about cost control. It's not just which model is cheapest, it's across all my ventures. Which model should I route this particular task to so that I'm optimizing cost and capability together? That's a much harder problem, but Optiac is essentially saying that's the infrastructure you need to think about building early before you have a sprawling mess of uncoordinated AI usage. So we've talked about maintaining agents after they ship, and we've talked about orchestration layers for routing requests intelligently. But there's a layer underneath all of that where things get genuinely hard, and it's where theory breaks down completely. When you move from one agent in production to multiple agents running concurrently, especially when they're coding agents making real decisions, the operational complexity just explodes. InfoQ covered production patterns for parallel agent systems, and the problems are messier than most people assume.
So the jump from prototype to production isn't just run it on better hardware. It's that you suddenly have to think about orchestration challenges that don't exist in single-agent systems. What are the actual failure modes you're worried about?
Multiple directions. First, timeout handling. If you've got one agent talking to an API that gets slow, and that agent is blocked waiting for a response, what happens to the other agents queued behind it? Do they time out? Do they retry? Do they escalate? Second is partial completion. Agent A finishes its work successfully. Agent B hits an error halfway through. Agent C is still pending. Now you've got inconsistent state. The third is agent disagreement. Two agents looking at the same problem and suggesting completely different solutions. Which one do you execute? How do you arbitrate?
Okay, so timeout handling is about preventing one slow agent from blocking the whole system. That's why you'd implement fallback chains. If Agent A doesn't respond in 2 seconds, Agent B takes the work. But partial completion is gnarlier because now you need rollback semantics. If Agent B fails halfway, do you undo Agent A's work? And agent disagreement, that's almost a voting problem. You need consensus mechanisms or some way to decide which solution to trust. Are we talking about having a human in the loop for disagreement, or is this supposed to be fully automated?
That's the critical question. For some workflows, you need human review. But for others, especially in the coding work we've been discussing, you need automated degraded mode operation. Fallback chains, yes, but also priority queuing so critical tasks get resource allocation before non-critical ones. Token budgeting, so you don't accidentally spend your entire month's compute budget on one runaway job. Rate limiting per agent, so no single agent can saturate the system. And dynamic agent pool sizing, so if you've got 10 parallel agents running and 5 of them are starved for resources, you can spin down non-critical ones and reallocate their tokens to the critical path.
This is where the rubber hits the road for someone like the builders we've been talking about. They're launching multiple small ventures using Claude code, which means they probably have multiple coding agents running in parallel across different projects. Token budgets collide. One project needs heavy lifting, another needs quick turnaround, and right now, most of them are probably not thinking about any of this. They're just launching agents and hoping it works.
Exactly. And that's where operational maturity becomes the differentiator. You can build an agent that works in isolation. What you can't do easily is build multiple agents that work together reliably at scale without explicitly thinking through these failure modes. Resource management at scale, token budgeting, rate limiting, priority queuing, pool sizing, that's not a feature, it's a requirement. The moment you have more than one concurrent agent, these problems are not theoretical, they're immediate.
And the hard part is that these aren't issues you can solve with a library or a framework alone. You need observability. You need to know why Agent B failed. Was it a timeout? An API error? A logic error in the agent's reasoning? You need tracing so you can see what Agent A did before Agent B started, so if there's conflict you can debug it. You need metrics on token usage per agent, per job, per hour. Without that visibility, you're flying blind when things go wrong, and they will go wrong.
And here's what makes this relevant to the conversation we've been having about maintenance and harnesses. Remember when we talked about Vercel removing 80% of their agents' tools to make it better? That same principle applies at the system level. If you've got 5 agents running in parallel, and 3 of them are adding complexity without adding value, you should delete them. But you can only make that decision if you have observability and metrics. You need to know which agents are actually earning their keep, and which are just consuming tokens and creating orchestration headaches. That's the mature question at scale, as not what agents should I add, but what agents should I shut down because they're not contributing enough value to justify their operational overhead.
So the builders managing portfolios of small AI ventures need to think about this early, not after they've already deployed a sprawling mess of concurrent agents. Which means, understand your failure modes before you're in production. Build fallback chains into your architecture from day one. Budget tokens as a first-class resource, not an afterthought. Monitor agent disagreement, and build consensus mechanisms if you're going to have multiple agents voting on the same decision. And ruthlessly delete agents that aren't earning their complexity cost, because parallel agent systems at scale aren't harder than single agents. They're a fundamentally different kind of hard, and you need different operational thinking to manage them. All right, so we've been talking about infrastructure and agents for a while. But there's a more fundamental decision that gets made way too late in the process, and it shapes everything about how your system scales and what it costs. It's the decision between RAG and fine-tuning. And here's the thing. Most builders treat this as a technical question. It's not. It's a business architecture question.
Okay, so RAG is retrieval augmented generation. Basically, you're giving the model access to a knowledge base it can search and pull from. Fine-tuning is actually training the model on your specific data. But what makes one the right choice over the other? When does each approach make sense?
RAG is your answer when you're doing knowledge-intensive work that requires up-to-date information and frequent updates. Customer support is the classic example. You want your AI to answer questions based on your current documentation, your product roadmap, your recent policy changes. If you fine-tune on that data, you're frozen in time. 6 months later, your product has changed, your docs are outdated, and your model is giving customers wrong answers. With RAG, you update your knowledge base, and the next query gets the new information. Same with research assistants, content discovery tools, anything where the underlying knowledge is moving.
And fine-tuning is the opposite. You want to freeze something specific about how the model behaves. So if you're building something that needs consistent tone and voice, or specialized domain expertise, or you're working with proprietary formats that are completely different from what the model was trained on, those are fine-tuning problems. You want the model itself to internalize your specific domain knowledge, not look it up dynamically.
Exactly. Fine-tuning is, I want this model to understand my domain the way my experts understand it. Legal document generation is a great example. You don't want to retrieval augment your way through contract language. You want the model to understand your firm's specific interpretation of contract law, your standard clauses, your risk profiles. That lives inside the model's weights. Same with medical diagnosis or specialized technical workflows. You want domain behavior embedded, not looked up.
The cost structures are completely different, right? RAG has ongoing retrieval costs. Every query hits your vector database. Every search consumes compute. Fine-tuning has upfront training costs, but then inference is cheaper because you've already baked everything in. How do builders choose between a monthly compute bill versus an upfront training investment?
That's where the business decision comes in. RAG is a subscription cost model. You pay per inference, proportional to query volume. If your customer support volume doubles, your retrieval costs double. But if your docs change quarterly, that's fine. Fine-tuning is a capital expense model. You pay upfront to train, then inference is cheaper. But if your training data becomes stale, you're investing in retraining. For someone launching multiple small businesses, that's a critical distinction. One model fits a growing, knowledge-intensive venture. The other fits a specialized domain venture where you have deep proprietary expertise you want to encode.
And here's what jumps out at me. You've been saying one model fits, as if you have to choose one and commit. But in production, aren't most serious systems doing both? Using RAG for the knowledge layer and fine-tuning for the behavior layer?
Absolutely. Hybrid approaches are becoming the pragmatic standard. You fine-tune a model on your domain-specific expertise and your preferred tone and style. Then you wrap it with RAG for the knowledge layer. So the model itself understands your industry, but it's pulling current information from your docs. That combines the best of both, consistent domain behavior plus fresh information. The trade-off is that it's more complex to maintain. You've got a fine-tuned model you need to retrain periodically, plus a RAG system you need to keep updated. But the results are better than either approach alone.
So if you're launching a portfolio of small AI ventures, each one probably needs a different decision here. One venture might be purely RAG, customer support, up-to-date, knowledge-driven. Another might be fine-tuned, specialized domain work, where you're encoding proprietary expertise. And the temptation is probably to build the sophisticated hybrid system for everything. But that's premature optimization, isn't it?
That's exactly the trap. You launch a venture with simple RAG because you're launching fast, and you need to validate whether customers care. If it works, you iterate. Maybe you add fine-tuning later when you understand the domain deeply enough to make training worthwhile. Maybe you never fine-tune because RAG with good documentation is sufficient. The point is, you don't pay the complexity cost up front. You pay it only when it's earning its way, when it's actually improving go-to-market or competitive positioning.
And this connects back to everything we've been saying about domain expertise and architectural flexibility. If you understand your domain well, you can make the RAG versus fine-tuning decision from the perspective of what does my customer actually need, not what's technically impressive. For a venture in trading or electronics or music production, you might fine-tune because you have unfair advantage in domain knowledge. For a venture in customer support or research, you might go pure RAG because your moat is in the documentation and the tools, not in the model itself.
Right. And this prevents the premature optimization trap entirely. You're not trying to build the world's most sophisticated AI architecture on day one. You're choosing the simplest architecture that lets you validate your business hypothesis fast, ship with RAG if it works, add fine-tuning if the data justifies it, stay agnostic about the underlying choice, because your defensibility is in the domain expertise and the harness, not in how clever your AI architecture is. That's how you launch faster, iterate quicker, and avoid accumulating technical debt before you even know if the business works. Alright, so there's a free Codecamp course that just dropped on a topic that should matter a lot to builders managing multiple projects. It's about building what they're calling self-healing CI/CD pipelines. And the integration is elegantly simple. GitHub, OpenAI, and NA10 workflow automation all talking to each other. The idea is that when your deployment fails, the system automatically figures out what went wrong and fixes it without waiting for you to wake up and notice.
Okay, so self-healing sounds like a buzzword that could mean anything from slightly helpful debugging hints to fully autonomous repair. What does self-healing actually mean in this context? Because there's a massive difference between a pipeline that tells you what went wrong and one that actually fixes it.
That's the right skepticism. This is actual autonomous repair. A deployment fails, maybe a dependency version conflict, maybe a missing environment variable, maybe a service timeout. The pipeline detects the failure, captures the error logs, and sends that context to OpenAI with a prompt essentially asking, what's broken and how do we fix it? OpenAI reasons through the logs, diagnoses the root cause, and returns a remediation action. Then NA10 executes that fix. The pipeline reruns automatically. If it succeeds, you're done. If it fails again, the loop repeats. You wake up to a deployed system, not a failure notification.
So the flow is GitHub webhook fires on deployment failure, triggers an NA10 workflow. That workflow queries OpenAI with your actual error logs. OpenAI returns a diagnosis and suggested fix. NA10 executes the fix, and the pipeline retries. That's genuinely impressive because it's not static rules-based troubleshooting. It's reasoning about your specific failure in your specific context. But I have to ask, what happens when OpenAI's diagnosis is wrong? Can a bad remediation actually make things worse?
That's the operational reality you need to think about up front. You'd want guardrails. Maybe OpenAI can only execute fixes in non-production environments first. Maybe it suggests fixes, but requires human approval before applying them to main branches. Maybe it has a whitelist of allowed remediation actions, restart service, update config, rollback version, and refuses to do anything outside that scope. The course covers this because the threat model is real. But here's the win. Even if you require human review for the actual fix, you're getting automated diagnosis. Instead of waking up to a cryptic error log and spending 20 minutes understanding what broke, you wake up to a clear explanation and a suggested fix. That alone cuts your incident response time in half.
And this is where it becomes relevant to the portfolio approach we've been discussing all episode. If you're launching multiple small ventures, you probably don't have dedicated DevOps people for each one. You're probably managing deployments yourself, or with minimal infrastructure help. How much does automated diagnosis and repair reduce the maintenance burden across a sprawling portfolio?
It's significant. Think about the typical day for someone running 5 or 6 small projects. One goes down during your sleep. You wake up to a Slack alert. You SSH into the server, dig through logs, figure out it's a missing environment variable. You fix it. It takes 30 minutes of your time, and you've completely context switched out of whatever you were working on. Now imagine that same failure happens, and you wake up to a message. Pipeline failed due to missing stripe eParse in production. Fix applied. Restored from backup configuration. Pipeline reran and succeeded. You glance at it, confirm it's sensible, move on. 30 minutes becomes 3 minutes. And because you're running this across multiple ventures, you're multiplying that savings 5 or 6 times.
This also bridges a gap that usually exists between traditional DevOps and modern AI-assisted automation. Traditional DevOps is deeply specialized knowledge. You need to understand Kubernetes, container orchestration, infrastructure as code, all the heavy machinery. But this approach, GitHub webhooks, N8N for orchestration, OpenAI for reasoning, these are all accessible to builders without deep infrastructure expertise. You don't need to be a DevOps expert. You just need to know how to wire platforms together and let AI do the reasoning. That's a democratization of operational automation.
Exactly. And because N8N is a visual workflow builder, you can actually see what's happening. You're not writing complicated shell scripts or infrastructure code. You're building a workflow in a GUI. When GitHub sends this webhook, extract these fields, send them to OpenAI, take the response and do this action. Even a builder without deep infrastructure knowledge can understand that and maintain it. And the course itself is hands-on. You're actually building the system, not just learning theory. That's the opposite of the usual DevOps learning curve.
So to bring this full circle, you're launching multiple small AI businesses. Each one has deployment pipelines that occasionally fail. Without this setup, each failure is a context switch, manual diagnostics, manual remediation, potential downtime while you figure it out. With self-healing pipelines, failures are detected, diagnosed, and fixed autonomously. You get a summary in the morning, your mean time to recovery drops, your operational burden drops, and because the whole thing is wired together with accessible platforms, you can actually maintain and iterate on it without being an infrastructure specialist. That's a meaningful quality of life improvement when you're running a portfolio. So let's take a step back and look at what today actually adds up to. We started the show talking about Anthropic's data, showing that domain expertise matters more than coding skill. We moved through the Chinese models, compressing AI costs by a factor of 6. We talked about the inevitability of frontier capabilities arriving regardless of policy. And we've been drilling down into the infrastructure and operational patterns that separate builders who ship once from builders who actually maintain systems. What's the connecting thread here?
Economics and maturity. We've moved from a moment where frontier AI was expensive, closed, and locked behind OpenAI and Anthropic's APIs, where your only real choice was paying premium prices for access. Now, in June of 2026, you've got open weight models that are cheaper and better. You've got self-hosting becoming viable with salvaged hardware. You've got orchestration layers that let you route across models without lock-in. The cost of the underlying infrastructure just collapsed. And at the same time, the operational patterns for what breaks in production are becoming clear. Agents break when harnesses drift. Systems break when you haven't thought through failure modes. Self-healing automation is becoming accessible. This is the moment where AI tooling moves from "this is a cool research project" to "this is how you actually build businesses."
And that's where the domain expertise insight becomes strategic, rather than just interesting. Early in the episode, we said that domain expertise matters more than coding skill, that a person who understands trading, or music production, or electronics can extract more value from Claude than a formally trained engineer who doesn't understand the domain. I think that insight is more true now than it was 6 months ago, and it's going to be even more true 6 months from now, because as the tool commoditizes, as you've got open models and self-hosting options and cost compression, the only durable competitive edge is understanding your domain better than your competition understands theirs. Coding skill becomes table stakes, the tool becomes interchangeable, but domain expertise stays scarce.
And that's the permission structure for builders who've been hesitating. You don't need to be a world-class engineer to launch multiple small AI-assisted ventures. You need to be domain expert in trading or music or electronics or whatever your field is, and you need to understand enough about AI systems to know what breaks and how to maintain it. The Vercel lesson was about maintenance. The parallel agents lesson was about operational patterns at scale. The self-healing pipeline lesson was about using accessible platforms to reduce your manual burden. None of that requires deep infrastructure expertise. It requires understanding your domain, being willing to maintain systems, and staying flexible about which tools you use. Those are skills that are actually teachable and learnable at speed.
Here's what I think marks today as a maturation point. For the past 2 years, the conversation around AI has been dominated by hype. What's the next breakthrough model? Who's going to own the AI infrastructure? Is this going to replace all jobs? That's all real, but it's also the conversation of people who don't have to actually ship and operate systems. The conversation that matters now is, how do I maintain this agent as the model improves? How do I route requests across models to optimize cost and capability? How do I avoid building infrastructure that gets locked into a vendor whose pricing or availability might shift? How do I diagnose and fix failures autonomously? Those are not the questions of AI hype. Those are the questions of operational maturity.
And the fact that we can answer those questions now, with clear infrastructure patterns, with accessible tools, with cost-competitive models, with documented operational practices from companies like Vercel and OpenAI and Anthropic, who've actually run these systems at scale, that's the real shift. You can launch a venture in June 2026, knowing what's going to break in December. You can design for those failures up front. You can avoid accumulating the kind of technical debt and operational burden that kills small ventures. You've got better tools, cheaper infrastructure, and genuinely clearer patterns. The maturation is real.
So if you're listening to this because you're thinking about launching an AI-assisted business or scaling one that's already running, here's what today's episode is really saying. Domain expertise is your defensible edge. Architectural flexibility, avoiding lock-in, staying portable across models, that's your insurance policy. And understanding what breaks in production before it actually breaks is how you stay ahead. The tools are getting better, the models are getting cheaper, the infrastructure is becoming more accessible, but none of that matters unless you're building on the foundation of real domain knowledge and real understanding of your customer's problem. Build there. Everything else is leverage.
And that's where we're landing. This week, June 17th, 2026, is the week when frontier AI moved from breakthrough to infrastructure. It's still changing fast, new models are still shipping, prices are still compressing, policy is still shifting, but the underlying pattern is clear. Cost is down, your optionality is up, and the builders with domain expertise are moving faster than everyone else. Tune in tomorrow for more from the frontier, because we're definitely not done with this.